What up, mathletes? Whoop, whoop. All right. This is your warm-up. Answer true or false, given the information. Let me move my picture a little bit out of the way. All right, let's go. Make sure and pause this because I'm going to get going. DC is parallel to AB. I don't know. They don't tell me anything about these lines, so I've got to call that one false. And why is it false? Because we don't have enough information. I don't know enough about these lines to make that statement. Measure of angle B, A plus measure of angle B plus measure of angle C plus measure of angle D equals 360. Well, has 1, 2, 3, 4 sides, and we know that n minus 2 times 180 should give us the degrees that the angles measure up to. So let me go ahead and replace n with 4. 4 minus 2 is 2. 2 times 180 is 360. So this is true for number 2. AD is congruent to BC. AD is congruent to BC. I have no idea. I don't have enough information. That's false. They haven't told me anything about these lines. Now, here's where it's important. If DC is parallel to AB, so DC is parallel to AB. Remember, that's the parallel sign. And AD is parallel to BC. So AD, oh, I'm drawing these nice, is parallel to BC. Then DC equals AB. DC equals AB. That's true. And AD equals BC. That's also true, because they're opposite sides of parallelograms, right? If they're both parallel, it's a parallelogram that's created, which means it doesn't really matter how bad the drawing looks. We can say those sides, so this is all true. Awesome. Pause if you need to. Let's move on. Tests for parallelograms. We're going to do some tests. Printable above this video is a toolkit. Remember, the toolkits can be used on tests. They can only contain the theorems we're talking about, but they're beside your notes, able to be used on test. I call that awesome. So you should be writing these down. I recommend, so these are theorems, conditions for parallelograms. Last time it was theorems, properties for parallelograms. Now we're doing conditions for parallelograms. We're almost going the opposite direction, right? One was saying if it's a parallelogram, we know this is true. Now we're saying, going backwards, saying if this is true, then it's a parallelogram. And here's what we're saying. So we're going to do 7, 9, I think 10, 11, 12, maybe. I think it's 4. Yeah, we have 4 more theorems. So 7.9, if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So we're saying if opposite sides are congruent, like AD is congruent to BC and AB is congruent to DC, then we know this whole thing is a parallelogram and all the properties of parallelograms apply, which is awesome. I would write down the symbols and the examples. I'm going to stop on each one briefly, pause it, write it down, then go on. Okay? Go on to the next one. This one says, all right, if both pairs of opposite angles are equal, so we're saying, or congruent, so opposite angles are congruent. If that's true, then the quadrilateral is a parallelogram, right? Boom. Write this example down. Pause it if you need to. Let's go. And this one's awesome too. 7-11. We did this one, right? Yeah. 7-11 says if the diagonals bisect each other. So if you can prove that these diagonals are bisectors, so they cut each line in half, each of the diagonals cut each other in half, then the quadrilateral is also a parallelogram. Again, pause this, write it down, let's move on. And last but not least, if AB is perpendicular to DC, so if AB is perpendicular to DC and AB is congruent to DC, then ABCD is a parallelogram. So if you have a set of sides that are parallel and congruent to each other, then the lines connecting them must also be congruent and parallel. They just have to be, and therefore it is the quadrilateral is a parallelogram. Perfect. Pause if you need to. Let's roll. It'll be a good day. Oh, determine whether the quadrilateral is a parallelogram. Justify your answer. Well, let's look at it. Opposite sides are congruent. Yes, it's a parallelogram. How do we know it? Well, if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. It doesn't even give the theorem. Remember, you'll notice it gives the reasoning. The reasoning is the opposite sides are congruent. Boosh. Let's check it. Yeah, the uncomfortable noise, but I'm going to reset it too, because if I don't, then it'll be up next time to try to teach it. Awesome. I think we're good there. Use parallelograms to find values. All right. The top of the eraser appears to be a parallelogram. Find the values of x and y so that the size of the eraser is a parallelogram. All right, so we're just going to assume. What do I know about opposite angles of parallelograms? I know that they're equal. And so because of that, if I'm going to set these equal to each other, it'll force these to be a parallelogram. So I'm going to say, all right, let's start off with the easy first. I'm going to do 5x, or 56, excuse me, equals 7x. Right? You know how to solve that. And again, pause this if you want to solve it yourself. Divide both sides by 7. And we get that x equals 8, or 8 equals x. So we know x equals 8. And then let's solve for the y that'll make this true. So I'm going to have 4y plus 4 equals 5y minus 26. So here's what I'm going to do. I'm going to subtract 4y from both sides and add 26 to both sides. And what do we get? Those are gone. 4 plus 26 is 30 equals y. Boom. And we can always check to see if this is true. 56, well, we know this has to be 56. 7 times 8 is 56, so that'll be 56 right there. And then 5 times 30 is 150, and 150 minus 50 minus 26 equals 124. And just to further confirm, so we know this angle is really 124, and to further confirm this is true, these should be supplementary. If it's a parallelogram, 124 plus 56 is indeed 180, so they are supplementary. But let's try this angle down here. We don't even have to, it should be, but let's confirm it. So I'm going to get 4 times 30. Oh, I put 130, I meant just 30. 4 times 30 is 120, and then plus 4, right? That's a plus 4. I thought I said a minus 4 for a second. It gave me a pause. I was like, what did I do? Equals 124. Boom, and it matches up. Perfect. Awesome. That's what we do. Okay, let's do this. Pause if you need to. Let's go. Artists often create sculptures in the form of geometric shapes. This sculpture appears to be a parallelogram. Find the values of x and y so that the sides of the sculpture is a parallelogram. Well, if it's a parallelogram, what do we know? We know that each of the triangles should bisect, or each of the diagonals should bisect each other. So because of that, if I set each side of a diagonal equal to itself, I'm going to force this into a situation where the x and the y create a parallelogram. So 3x minus 1 equals 2x plus 3. X minus 1 equals 2x plus 3. And I'm going to subtract 2x from both sides. Since I subtracted 2x, I'm going to move 1 over to the other side, plus 1. And I get x. Cross that out, equals, cross that out, 4. Awesome, so x equals 4. A different color. Let's go with green. Okay, this time I'm going to do 6y minus 1 equals 4y plus 3. 4y plus 3. I'm going to subtract 4y from both sides. And then add 1 to the other side. 2y, that's gone, equals, that's gone, 4. Divide both sides by 2, and I get that y equals 2. Boo, so x equals 4, y equals 2. Pause it if you need to. I'm going to erase this. 4 and 2, 4, 2, just to confirm we did it right. And select the theorem you used to find it. Well, I used the fact that if diagonals bisect each other, then the quadrilateral is a parallelogram. Look at that, a twofer. Awesome. And we're going on. This is a 2-day lesson. We're just going to finish it up in one. I think we can do it pretty quickly. One video would be great. We can use the distance, slope, and midpoint formulas to determine whether a quadrilateral in the coordinate plane is a parallelogram. Determine whether the quadrilateral FGHJ is a parallelogram. Justify your answer using the midpoint formula. Okay? Well, here's the deal. I'm going to use the diagonals. If the diagonals each share the same midpoint, then they bisect each other. If they don't, then they don't bisect each other, and it's not the quadrilateral. So this point right here is what? Negative 1, 2, negative 1. So I've got negative 2, negative 1. And G is 1, 2, 3, 4, 1, 2. So that's 4, 2. All right, to get the midpoint of JG, so I want the midpoint of the line created. I'm going to try to draw my best. There we go. JG. I want to find that middle area. Midpoint of JG. Remember, it's just adding the x value. We're going to average the x and average the y. So we're going to add the x values together. So negative 2 plus 4. Divided by 2 should be my midpoint x value. And to get my y values, I'm going to add them together. Negative 1 plus 2. And divide that by 2. You just average the points. And let's get that. Negative 2 plus 4 is 2. 2 divided by 2 equals 1. And negative 1 plus 2 is 1. And 1 divided by 2 is just 1/2, right? Just going to leave it like that. Now, I want to find, let's get a different colored pen. I'm going to go with red. I need to find the midpoint of FH. Now, F is the point negative 1, 2, 1, 2, 3, 4, negative 2, 4. And H is the point 1, 2, 3, 4, negative 2, 4, negative 2. And hopefully we come up with the same exact midpoint. So I want to find the midpoint of FH. And that should equal, we're going to average our x values, which is negative 2 plus 4. Doesn't matter what order you write those in, divided by 2. And then I'm going to do average the y values, which is, again, negative 2 plus 4. Divided by 2. Negative 2 plus 4 is 2. And negative 2 plus 4 is 2. So what am I going to get? Equals 2 divided by 2 is 1. 2 divided by 2 is 1, 1, 1. Those are not the same midpoint. The midpoint for JG is 1, 1/2. And the midpoint for FH is 1, 1. They're not going to meet at the same spot, which means they are not the bisectors of each other. They would have to have the same midpoint to be bisectors. So because of that, I can say, using the midpoint formula, these are definitely not bisectors of each other. All right. So pause this if you need to. I'm going to erase it. Identified parallelograms in the coordinate plane. I need to move my picture just a tad. Determine whether the quadrilateral KLMN is a parallelogram using the slope formula. Okay, now we're going to use what we know about slopes. Remember, slope is just, so RM equals rise over run, which is our change in Y over change in X, which we can do by going, what's Y2 minus Y1 over X2 minus X1. My mouse writing has gotten a lot better. We should all acknowledge that right now. Just saying. Okay, so let's come up with all our points. We got point K is 1, 2, 1, 2, 3. So that's 2, 3. Point L is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 8, 4. N is 1, negative, 1, 2, 3, so 1, negative 3. And M is 1, 2, 3. Well, this is 8. M is 7. 7. And down 1, 2, 7, negative 2. Let's find all their slopes. Should be, if Kn and Lm have the same slope, then they're parallel. If KL and NM have the same slope, they're parallel. And then we can use the side that opposite sides of quadrilateral are parallel, mean that it's a parallelogram. Oh, sorry. Let's stretch it out. Let's try it out. So I'm going to subtract their y's. So I'm going to have for KL, it's going to be subtracting these two, so I'm going to have 4 minus 3, since I start out with 4, right? Over 8 minus 2, which equals 1/6. Okay? So this is 1/6. Booge. NM, so NM, let's see if that's 1/6. So I'm going to have negative 2, right? Minus negative 3. Remember, I always point it back. So I'm going to have negative 2 minus, and then that's a negative 3, right? Don't confuse those negatives. And then I'm going to have 7 minus 1. So those two negatives make a positive. Negative 2 plus 3 equals 1. 7 minus 1 is 6. Well, this looks promising, so those are definitely parallel to each other. So I can say NM and KL are parallel. Now we just got to prove the next one is. I'm going to do that in red. So now I'm doing KN. So I'm going to take the 3 and subtract a negative 3. 3 minus negative 3 all over 2 minus 1. Which equals, let's see, it's going to be 3 plus 3, right? Which is 6 over 1, or simply 6. And then last but not least, I'm going to subtract these two, so I'm going to have 4 minus negative 2. Do it out here a little bit. Well, no, I got room. 4 minus negative 2, all over 8 minus 7. 8 minus 7, which again, that becomes plus. 4 plus 2 is 6. 8 minus 7 is 1. Look at that. They have the same slope of 6. Therefore, is this a parallelogram? Quadrilateral KLMN is a parallelogram. Boom. Awesome. This is a good problem. All right, pause if you need to. Let's move on to our last one. Proof. Ooh, this is a goodie. Let's finish this up strong. So first things first, we're given that angle AC bisects DB. We see that because those two lines are congruent on either side of the bisector. Prove that ABCD is a parallelogram. Well, if AC bisects DB and DB bisects AC, then what do I know? I know that AE equals CE and DE equals BE, which is right here, or AE equals EC. Come on, where do we go? There we go. All right. So now we know those are true. That's the definition of bisector. Now it says angle AED is congruent to angle CEB. Well, aren't those vertical angles? Yeah. And what I missed was it also said angle AEB. I think it's AEB. Yeah, AEB is equal to angle CED. So now we've proven something else. We've proven that this angle equals this angle, and these angles are congruent. Now, unfortunately, I got to get rid of these lines as soon as I start go back. But that's what we just stated right there, and that's just from vertical angles. If they're vertical angles, they're congruent. Okay. Now, let me draw that back. When I made this statement right here, I've just done something. I can say that triangle AED and triangle CED are congruent because of side, angle, side. That's an old theorem, side, angle, side. It just says any two triangles that have two sides and the in-between angle congruent to each other are fully congruent. And I did the same thing for triangles AEB and CED. Again, side, angle, side. I can use that and say, hey, these are congruent to each other. So now I know that this triangle is congruent to this triangle and this triangle is congruent to this triangle. Perfect. That's side, angle, side. And if that's true, here's a new deal for you guys. CPCTC. I always call it CPCTE, but anyway, CPCTC is just congruent parts of congruent triangles are congruent. Back in the day, I learned it with an E. It just meant they're equal. The same thing, they're congruent. So congruent parts of congruent triangles are congruent. And all that means is, if I'm telling you I have two congruent triangles, then all parts of them are congruent. So because we just proved they were congruent with side, angle, side, which I forgot to put up here, since all these triangles are congruent, I can say all their different legs are congruent. And if all their different legs are congruent from congruent parts of congruent triangles are congruent, then I know that ABCD is indeed a parallelogram, because if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. Boom! Let's check it. Are you ready? Awesome. That's it for today. It's time to get on with your bad selves. Let's get that math done. Peace out.